What is going on, everybody? In this video, we're going to talk a little bit about transfusion reactions. Again, this is kind of like the hypersensitivity syndromes, the immunodeficiencies, the transplant rejections. There's kind of just a bunch of different categories of pathology that you should be familiar with. And a lot of these can be distinguished based on some very unique things, either in the presentation, the diagnostics, or the management. And so we'll start here with the acute hemolytic reaction. Now, the acute hemolytic reaction is probably the highest yield of the group. And so that's why I think it's a good one to start with. But not only that, I think this is a great opportunity to just kind of talk about these red blood cells and review what antigens are typically going to be on the surface of our red blood cells. And when we talk about the different red blood cell types, right, we have different groups. So we have group A, group B, we have a combination A, B, and group O. And what this is referring to, what this A is referring to, is just this antigen here on the surface of the red blood cell. So these red blood cells have an antigen that we'll just call the A antigen, which means, again, if this is an antigen, right, potentially if I had an anti-A antibody, right, an anti-A antibody, that antibody could potentially bind to these antigens and then mark them for destruction. And this is exactly what we talked about when we talked about type 2 hypersensitivity reactions. We had antigens that were on the surface of cells that antibodies bound to and then marked those red blood cells for destruction, primarily mediated by complement. And so that's the concept here. So these red blood cells, this group A, has A antigens on their surface. So anti-A antibodies could target these antigens potentially. Okay, so that's the concept. Now, if we go to group B, right, group B is the same kind of thing. So group B is going to have these green antigens you see here, right? Those are the B antigens. And then we can have a combination where we have an AB group. So the AB group, right, is going to have A antigens as well as B antigens. So they have the A and they have the B antigen on the surface of their cells. Then there's the group O, right? Group O is going to have no antigens on their surface. So group O, we can see here, no antigens on the surface of the red blood cell. Okay, so with that being said, the point here is if I have a patient that has a group A blood type, in other words, if they have these A antigens on their surface, these patients will likely have anti-B antibodies. Okay, so they're going to have antibodies against the B antigens, but this works out because these patients have all of this A-type blood, so their blood should not be targeted by the B antigens. Now, on the flip side of that, if I were to give this patient with group A blood, if I was to give them some blood that had the B antigens on them, now these anti-B antibodies would go after those cells, right? They would target these cells and mark them for destruction via type 2 hypersensitivity reactions. Now, notice the structure here of these antibodies, of these anti-B antibodies. Notice that these are pentameric, right? And this pentameric structure, remember, this is very classic for an IgM antibody, right? So this is very classic for an IgM antibody. And it's going to be pentameric, okay, but it's going to have 10 binding sites, right? Each one of these that I'm kind of making a circle over is a binding site, okay? So when we're talking about antibodies in the plasma here, we're mostly talking about IgM. That's going to be doing a lot of the damage here. That's going to be mediating this process. And again, the point being, if I have a patient that has a group A type blood, and I give that patient some blood from another person, potentially that's group B, that person's group B antigens will be targeted by the anti-B antibodies in that group A type blood. That's the big point you want to take home here. Now, conversely, right, if I had a patient that had a group B type blood, right, if I had a patient that had a group B type blood, and then I gave that patient group A type blood, okay, so if I gave this patient some blood from a patient that has the group A antigen, then those anti-A antibodies that would be present in this patient would then target these cells for destruction once again. So it's kind of the same concept. Now, where it gets a little tricky is what if I have a patient that has group AB type blood? Okay, so they have the A and the B antigens. Well, the point is, if the patient has A and B antigens on their red blood cells, they're probably not going to have any antibodies in their plasma against these cells, right? Otherwise, these antibodies would have already targeted their red blood cells for destruction. So these patients will usually not have any antibodies in the plasma. So the point here is, if I were to give this patient some group B type blood, or if I was to give this patient some group A type blood, in both of these situations, these donors' red blood cells shouldn't really be targeted for destruction because there's no antibodies to target them for destruction. So that's why we say in general, type AB blood is classified in the category as the universal recipient. So type AB blood, universal recipient, because I can give blood from group A or group B and not have to worry about those red blood cells being marked for destruction. Now, on the other hand, what about if I had a patient that had a group O type blood? So if I have a patient with group O type blood, this patient doesn't have any antigens on their surface. Okay, so type O, you can think of this as a 0, if that helps you remember it, that there's no antigens on the surface of the red blood cell. If there's no antigens here, then I might have anti-A and anti-B antibodies. In other words, if I gave this patient blood that had the B antigen, those cells would be marked for destruction by my anti-B antibodies. And along that same length, same thing for group A, right? If I gave them group A blood that has the A antigen, this patient will likely have anti-A antibodies that will target these cells for destruction. So the group O patients will really only be able to receive blood from other group O type patients. I can give these red blood cells to any of these other patients, right, and not have to worry about antibodies targeting the group O type blood because there's no antigens on the surface of the group O type blood. There's nothing for these antibodies to target. And when I say there's no antigens, I'm just referring to, group A, group B, right, just for simplicity's sake here. But the point is I can give this group O type blood to a group AB patient, to a group B, to a group A, and not have to worry about antibodies targeting it. Like there's no A antigens, there's no B antigens to destroy these cells. So that's why we say type O is the universal donor. But remember, if I was going to donate blood to a patient that had type O, I can only use type O because otherwise I would have these antibodies targeting those red blood cells. Students will understand the concept here with type O, type AB, right? Type O being the universal donor, type AB being the universal recipient. But where it gets tricky is when you start adding in things like fresh frozen plasma transfusions. This is where test writers build on this concept and make you think a little bit. Okay, so the easy way to remember this is if you remember the red blood cell transfusions being type O as the universal donor, type AB as the universal recipient, you just have to flip those to understand who's the universal donor with fresh frozen plasma and who's the universal recipient. So let me explain this though, because I think it actually makes a lot of sense here. So remember, the first things first, if I take a sample of some patient's blood and I spin it in a centrifuge, right? The erythrocytes are typically going to be on the bottom here. And the erythrocytes are going to be these red blood cells that we're talking about here, right? And then I have some buffy coat that's going to be my leukocytes, my platelets, and then I have all of this plasma, right? So this is all plasma up here that's going to kind of sit on the top of the centrifuge, okay? And that plasma is what we're talking about here. The antibodies, right? The antibodies are going to be in this section, most likely, of the plasma, okay? So if I'm giving somebody plasma, right? If I'm giving them this portion here, I'm not giving them the red blood cells. I'm just giving them the plasma now. That's what we're talking about, right? Fresh, frozen plasma transfusions, not red blood cell transfusions. Okay, so if I give the patient this portion here, the plasma with the antibodies in it, let's say that I have a patient that's group A and I give them group B plasma, right? What's going to happen? If I give a patient that's group A, group B plasma, these anti-A antibodies are essentially being given to this patient, right? And so the donor's pentameric IgM antibodies are going to target the recipient's red blood cells, okay, and they'll mark them for destruction. Okay, so that's the concept. So we wouldn't want to do that, right? Because we're taking this box now and moving it into our patient. And the same is true if I had a group B patient and I gave them some group A plasma, right? If I gave them these antibodies, that would mark my red blood cell with the B antigens for destruction. Okay, so that would not be what we want to do. You might be saying, okay, well, wouldn't it be simple if we just didn't give any antibodies to the red blood cells in the sample? And that's exactly what group AB blood has. It has no antibodies to A or B, right? So the antigens are already on all these red blood cells. So like we said, we don't really have any antibodies in the plasma. So that's why group AB are going to be the universal donors for plasma because they don't have any of these red blood cell antibodies to target cells for destruction. So I can give group AB blood to someone that has group B blood, to someone who has group A blood, to someone who has group O. And I don't have to worry about the antibodies targeting the cells for destruction. And so that's why type AB blood is going to be the universal donor. Again, just the opposite of what we saw with red blood cell transfusions. Now, type O in this situation is going to be the universal recipient. And the reason for that is because type O blood doesn't have any antigens on its surface to mark it for destruction, right? There's no A or B antigens here to mark it for destruction. And so I can give this patient plasma from a group A patient, right, that has anti-B antibodies and not have to worry about them targeting the cell because there's no antigens to target. The same thing is true from group B plasma. The same thing is true, obviously, from the universal donor, group AB, because there's no antibodies at all in this patient's plasma. Okay, so that's why type O blood is the universal recipient. Okay, again, just the opposite of what we talked about with red blood cell transfusion. So that's where it gets a little tricky. If you're in a rush and you're not sure, go back to your red blood cell transfusion concepts and just flip it. And that's the easy way to understand that. But a lot of times, test writers will try to test your critical thinking of this concept, and you might actually have to understand some of what we just talked about to get the question right.